Ladies and gentlemen, the SUSE and Rancher community proudly presents Front Row at KubeCon.
Good morning, everyone, and welcome back. A plane, because it's the last day of the conference, so I said, yeah, sure, I'll come out from behind the camera and I'll fill in. I am joined this morning by Sanjay Nadavajala from the Opna team, and he's going to tell us a little bit about Opna, one of SUSE's new open source innovation projects. Hello, Sanjay.
Hey, Adrian, thanks for having me. So Opna is the AI Ops for Kubernetes project, started at Rancher Labs SUSE.
Okay.
It's about taking logs, metrics, and events, basically all types of data that's emitted by your Kubernetes cluster, ingesting it, and giving back AI insights into whether something is anomalous, suspicious, or if everything's normal, which is what you want.
So it's event event processing for, or anomaly detection for events and logs.
Correct.
Okay. So where does this fit? Like, what problem does this solve in the ecosystem? Where do you see this? Where do you see this landing?
So basically, Opna's goal is to reduce mean time to detection and mean time to resolution. So typically, what happens with a lot of this data that's emitted by Kubernetes clusters is after the fact, when an outage happens, you go into your log messages, you go into your metrics, and you try to diagnose what happened, right? So all this data already exists. So why not ingest it as it comes and have Opna be a preemptive, proactive solution that will alert you if things are escalating up to a potential outage.
All right, so I come from the managed services space. This would have been wonderful to have 10 years ago. Can you show us? Can you give us any kind of a further information about it?
Yeah, I'm going to show a demo.
Okay.
So before I jump into the demo, I just wanted to quickly tell you guys out there that, again, you have your Kubernetes cluster. It's emitting different data points like logs, metrics, and events. And so Opna is installed into your Kubernetes cluster, similar to how you would install Prometheus into your cluster. And Opna is running inside of your Kubernetes cluster. If you have a GPU, then you can enable our GPU acceleration and take advantage of our deep learning models. But if you don't have a GPU, that's fine. Opna comes with a pre-packaged, pre-trained model that is going to give you insights into the etcd and control plane. If you're running RK1, RK2, K3S, or other vanilla Kubernetes, anything but managed Kubernetes clusters.
Can I interrupt with a question?
Yeah.
So you just said that you don't need a GPU to use this.
Correct.
I thought the reason that I haven't played with this is because I don't have access to GPU clusters.
Yeah.
Where's the delineation between when I would need a GPU versus when I wouldn't?
Yeah, so if you don't have a GPU, we want people to take advantage of Opna by leveraging Rancher Labs Kubernetes expertise, which we've packaged into this pre-trained model. It's going to let you know if anything within your etcd or control plane is wrong. Okay. And what we've done is taken our deep learning model, pre-trained on a bunch of log messages that we've simulated and collected from support team as well as our own simulations from K3S, RK1, RK2, and vanilla Kubernetes, pre-trained this model, and this model runs on the CPU. And we've also introduced other optimizations. We introduced this thing called a caching mechanism where it significantly reduces the number of lookups, basically the amount of times that you use CPU. Because behind the scenes, what we're doing is we're taking log messages, reducing it to log templates, and then looking up these log templates within our caching system and seeing if we have predictions for them already. So we made a bunch of optimizations to basically have a deep learning model, which is pre-trained, run on CPU.
And that model is updatable, I imagine, on the fly?
Yeah, so we update it very frequently based off new log messages that come in and that we're collecting.
Okay, fantastic. So let's continue to show what we got.
Yeah, so basically, so we have log anomaly detection. That's the feature that we first started off with. We recently introduced metric anomaly detection as part of our v0.2 release that just came out last week. I'll talk about that a little bit more, but it's in experimental mode. I'll show you guys what that looks like as well. But imagine that you're a SRE or an operator of a cluster, and you're collecting log messages. You're sending it to tools like the Elk Stack or Splunk or Datadog. And typically, you won't look at your log messages because why look at them unless something is already...
There's just so many of them.
Exactly.
Look at them to go to sleep.
Exactly. So in this simulation cluster that we have, we're running this application named SockShop, and Over the last 24 hours, it's generated 1.4 million log messages. Not much compared to a real-life production system, but 1.4 million log messages. I don't think you want to look at it. I definitely don't want to look at it.
No.
You have no clue what your cluster's health is just by looking at this Kibana dashboard.
Right.
And so what we want to do with Opni is give you a bird's eye view into your cluster's health by leveraging log messages initially. And we just introduced metric anomalies. I'll show that as well.
Okay.
But let's move on to the Opni dashboard. So this is the Opni dashboard, and over the last 24 hours, we saw that there's 1.3 million log messages. The Opni Insights panel on the top left gives you a bird's eye view, what's going on inside of your system. We classify every single log message as normal, suspicious, or anomalous. And so as we can see over here, we now have an idea. If we highlight anomaly, there's not many anomalous log messages in the system in the last 24 hours. And so let's say you are interested in the anomalies, right? What you would do is move on to this panel, the anomaly panel, which breaks down where do your anomalies actually lie. Do they lie in the control plane, or do they lie within your own workloads? So over here we see that there's a big spike in anomalies in your workloads, and not too many in the control plane, which is good, means your cluster is healthy. So if you want to further investigate what's going on, you would take a look at these bottom two panels, which is the etcd control plane logs that you should investigate, as well as the workload logs you should investigate.
And it's worth noting for those of you who are watching, like you see that this log field is very, very narrow. We have this zoomed in 6 times so that it shows up well on the screen. This actually fits really nicely into a normal size browser.
Yeah. Also, we have a custom UI coming out. It's also in experimental mode, but look out for it in the next few weeks because it's going to be stable. And instead of using a Kibana dashboard, we're going to have a custom UI.
Oh, okay, that's great.
So, yeah. What I do want to highlight is out of 1.4 million, 1.3 million log messages that we saw in the original dashboard, if you go in as an operator and you're looking to get an idea of your cluster's health, you really have no idea. But now we know exactly what the cluster's health is. Basically, we see way more normal than suspicious or anomalous.
Yep.
And out of those suspicious and anomalous, you can actually go in and explore. So instead of looking at 1.3 million log messages, you have 85 log messages to look at.
All right, that's a much more manageable number.
Yeah. And so let me quickly show you what a control plane fault looks like and how fast the pre-trained model actually is able to catch a failure that we inject.
All right, you gonna pull the plug out of something?
Yes.
Nice.
So this is our cluster that we're using right now. We have 3 etcd control plane nodes, 3 worker nodes. What I'm going to do right now is just take down one of the etcd.
Okay.
This is etcd failure, right? So
shoot it in the head.
Okay, so we've taken down etcd. Let's go back to this dashboard. I'd like to mention right now that Opni is a streaming system, so everything's happening on the fly. Our models are self-learning, and they are constantly updating as it's recognizing steady states, new steady states. Let's say you run different workloads within the same cluster, right? You'll have multiple different steady states based off what workload. So our AI models are able to automatically capture this and retrain themselves.
Nice.
So let's go ahead and refresh this. We'll see that there's going to be a spike in anomalies, which we start seeing this spike right now. And it's gone from 9 to 2,000 etcd and control plane logs that you should take a look at. And I know.
Bad morning.
So this is really tough to read, but basically we identify which Kubernetes component this failure is happening in, or what log message that Kubernetes component belongs to. And so we see a bunch of kube API server messages. If we expand this, and it's hard to read here, but basically it's going to tell, this log message tells you that it's trying to hit this internal IP, it's unable to hit it. If we go into inspect or maximize panel mode, we'll see it a little bit better.
Yep.
And so over here, we see a bunch of connection refused to this internal IP. If you're an operator, what I'd do is just come here and see that this internal IP belongs to this guy right here. And so you know that's an etcd failure.
Yep.
By further exploring this, you'll start seeing etcd log messages as well. So you start seeing etcd failures here. Now you know it's an etcd failure. It's that same IP address. And so as an operator, you immediately know, I need to go fix this. And so, yeah, that's how you'd use log anomaly detection right now. Again, for the workload log messages, if you have a GPU, it will train a deep learning model and it will it'll automatically learn what is the steady state within your workloads. So the same process there. We're not going to demo that. You guys could try. I highly encourage you guys to try that out by yourselves. Let's talk a little bit about metric anomaly detection,
Okay.
which is the more standard offering in other AI ops tools in the marketplace. So basically, metrics give you a high-level insight into these signals that you care about within your cluster.
Right.
Depending on what workloads you're running, you might care more about CPU, memory,
Requests
throughput.
per second, errors per second.
Exactly.
Stuff that can help you determine the health of, beyond just actual log failure or
Exactly.
logged failures.
Exactly, and this is typically these are the metrics that operators use to get an idea of how their cluster is performing,
Yep.
like the Kubernetes golden signals,
Yep.
things like that, right? So other players, what they do is they run metric anomaly detection, and so that's exactly what we've introduced here. A lot of you guys are probably familiar with metric anomaly detection, so it's going to be nothing new to you. What we do is we forecast into the future, and anytime the real value breaches one of the forecasted values, the upper and lower bounds, it will basically trigger an anomaly.
Okay.
Right? And so why we started off with log messages instead of metrics is because we saw that forecasting into the future for metrics it's a problem that's been solved many times over, and it's not really leveraged well enough to make the operator's life easier. So if you're an operator and you go in, you visually see that there is a spike, you know something's wrong, right? You can set up static thresholds, and if it breaches that threshold, you'll get paged and you'll go check it out, right? But for log messages, it's a different animal because you just don't know unless you have
Sure.
some sort of smart system telling you this is outside of what's normal.
The example with the logs that you gave is a little bit contrived because you actually shut down a node, and that it would be easier for a regular system to detect.
Right.
But this is capable of detecting small, nuanced deviations from any baseline.
Correct.
And the baseline also moves as the system changes and evolves.
Correct. So what we've done with metric anomaly detection within Opna is we introduced dynamic thresholding, basically. So instead of setting a static threshold where you say, if CPU breaches 80%, send me an alert and I'll go check it out. Instead of that, what Opna does is, in your steady state, let's say CPU right now is around 7.5%. Because this has become the steady state, it's projected that anything above 9% is going to be outside of what is the steady state right now.
Understood.
Right?
Okay.
So it's no longer that 80%, and this is going to evolve based off your workloads. And of course, it's going to send out false positive signals. But where those false positive signals are mitigated is when we combine metric anomaly detection with log anomaly detection. Because metrics might find that to be anomalous when there's a spike in CPU, but right now there's not much CPU being used at all, right? So if we see that there's a bunch of metric anomalies as well as log anomalies, that's when the operator really knows, I need to go look at this.
Do you think that a system like this will actually help people feel better about putting logging systems into place because they know that they don't have to either just ignore everything or read them all?
I think so. So what we've done with logging is it's short-term retention. So you can decide how long you want to keep the log messages. We're not trying to replace a Splunk. We're not trying to replace a managed Elastic. What we're doing is we're keeping the logs for a short amount of time, and it's only being retained for 7 days by default.
Okay.
And so there's not much storage costs on the user's end, and yeah.
It's nice. It's like having a really smart intern watching the system 24 hours a day.
Exactly.
Nice. Really smart intern. Nothing against all of you who are interns out there. I'm sure all interns are smart. But you know what I mean. It's like having a person doing work 24 hours a day. It's like the perfect employee.
Yep.
This is really cool. How can somebody get started? Well, actually, before I ask that question, where does this fit into Rancher in the long term?
Yeah. So basically, in the long term, how this is going to fit into Rancher is we identify these anomalies within your logs, metrics, and soon you'll see in the custom UI, you'll see events as well. And so you get all these insights, but let's say you as an operator trust this system enough in the future for it to make configuration changes.
Oh, wow.
So what Opna is going to do is communicate with Rancher in the future. I injected an etcd failure, right? So that etcd, let's say like Opna has determined that node has gone down. It's going to communicate to Rancher, this node has gone down, just spin up a new node. And it's just automatically going to self-heal. So what we're doing, I like to tell this analogy, is we're trying to build the self-driving car of Kubernetes.
Yeah. That's a really, really smart intern. At that point, you can promote him to like an SRE.
Yeah.
That's really cool. So somebody wanted to get started with this, especially now that I know that you don't need a GPU system to get started. What are the minimum requirements for somebody to run this?
Yeah.
And where can they go to learn more?
So the minimum requirements are about 16 gig of RAM and 8 CPU. And out of those, if you reduce the retention of log messages, it's going to significantly decrease. You can also play around with some of the settings, but we do have two modes right now. We have a full install in which you can enable GPU acceleration. Let's say you don't have a GPU, then you can disable it and it's full install. Or you can do a simple install where you can go into Ubuntu VM and one-click install Opni, and it will install only the control plane etcd side of things. And you can go ahead and start checking it out. You can replay the same exact demo that I gave you guys, take down etcd, crash your system and see if Opni is able to catch it. So you absolutely don't need a GPU to get started.
Okay. And then where can people go to learn more about this?
Yeah, so you can go to opni.io to read the docs there. You can go to the Rancher Labs Opni GitHub repository.
Okay.
And so there's a bunch of documentation there. If the audience has any questions, please join our Slack channel and go to the Opni Slack channel and definitely post your questions there.
Is that on the Rancher user Slack?
Rancher users.
So that's the Opni channel on the Rancher user Slack. If you're not already there, you can get an invite by going to slack.rancher.io. Just putting your email address and Slack sends you an invite to join the workspace. Sanjay, this has been eye-opening. I really want to thank you for coming by.
Yeah, thanks for having me.
Front row at KubeCon. We'll be back in like 6 minutes with somebody else. Thank you for watching. We'll see you again soon.